Okay, welcome all of you. Again, today is after the quiz and Q&A, we'll do a big review day. So there's no new material to talk about. It's a lot less structured than normal days because I don't have a big list of things to do. But my plan is to help you guys practice. So let me share the screen and we'll take a look at the quiz. Okay, so here's your quiz. We have f of x equals natural log of x plus 1 over x. And part A is find any critical points on the interval 0.1 comma 2 and show your calculus work. Okay, so don't just give me numbers. I need to see what you did. Okay, remember there was a step-by-step process. What was the first step in finding critical points? I know it's been 2 days since we talked about it, but that's not that long. Find the derivative. Very first step actually is not to find the derivative, but to
differentiability everywhere.
Yeah, check to see if it's not differentiable anywhere. This one's an interesting one because there are issues, but the issues are where? Where is this not differentiable? Where is f of x not differentiable?
Side of the range at 0.
Yeah, 0, and actually all negative numbers too. ln of x is bad for negative numbers. You can't do it. So the good news is that it's not differentiable. Let's write that out. Or let's say it is differentiable for all x greater than 0. So within 0.1 comma 2, the function is differentiable. There's no issues there. Any questions on the first step? Okay, then we take the derivative. Okay, what is the derivative of ln of x plus 1 over x? So let's write this out. F prime of x equals, so what's the derivative of ln of x plus 1 over x? Not supposed to be too tricky. Yeah, so the derivative of ln of x is 1 over x. And the derivative of 1 over x is negative 1 over x squared. So minus 1 over x squared. Okay, that's the second step. Any questions in the next step, in that step? Okay, what's the third step? What's the third step on finding critical points? Yeah, we set it equal to 0. So now I'm going to take this and I'm going to set the derivative equal to 0. And let's solve. So I think the easiest is just multiply by x squared. And if you multiply by x squared, we get x minus 1 equals 0. Any questions on that? Okay, you better all be able to solve x minus 1 equals 0. What is x? So what's x? Yeah, x is 1. Any questions on this step? Okay, so we've now found the critical points and there's just one, and that's at x equals 1. So the only critical point is at x equals 1. Any questions at all on part A? Okay, B, without graphing, but with a regular scientific calculator, find the global extrema on the interval 0.1 comma 2. show your work. Okay, so what do we have to do? Where are the possibilities for global extrema? Right, in general, where do you look? Yeah, so the places we look are at the critical points and at the end points. So what I'm going to do is I'm going to make a little table. I think this is the easiest since this has a little table button. And we're going to have critical points and endpoints. So there are 3. And we're looking at x, and we're looking at f of x. And in particular, our x's we have to worry about are 1, that's the critical point. And then we also have 0.1. And then we have 2. Any questions so far? Okay, so now remember we have ln of x minus plus 1 over x. So 1 I can do in my head. ln of 1 plus 1 over 1 is 1, right? Because ln of 1 is 0, and 0 plus 1 over 1 is just 1. 0.1, I need the scientific calculator. That's why I told you. So I'm going to use the Google toolbar, and I'm going to take ln of 0.1, and then we have a plus 1 over 0.1. Any questions on that? And I get about 7.7. That was here. Okay, and then I do the same thing with 2. So we're going to take ln of 2, and then plus 1 over 2. And I get 0.916. Any questions on that? Let me double check if that worked. Yeah. All right, so we now have our possibilities. And once we have our possibilities, now it's time to say, what is the maximum and what is the minimum? So what is the minimum? I got it from 2. I was worried about 2. Let me look at this one more time. I knew there was a problem. Aha. That wasn't the answer. So I double check if I get, there we go, 1.19, much better. So 1.19. Oops. Try again. Okay. So now we got to use this fact. So we're asked to find the global extrema. Okay. So what is the global minimum? Yeah, global minimum is 1, and at x equal 1. And what is the global max? Yep, the global max is 7.7 at x equals 0.1. Because if the only possibilities are 1, 7.7, and 1.9, then the biggest one will be the max and the smallest will be the min. And that's it. Are there any questions at all on this particular quiz? Any questions? Okay, so it's a very step-by-step process. Let me just remind you the steps again. Step 1 is to look to see where there might be any issues with differentiability. And if it's not differentiable, then that's a possibility. Step 2 is to find the derivative. Step 3 is to set the derivative equals 0 and solve. And then step 4 is to list them all. And then if you want to find the max and the min, the global max and the global min, then you look at x and f of x, and the biggest f of x is the maximum, and the smallest f of x is the minimum amongst our candidates. Any questions at all on this quiz? Any questions? Okay, so if there's no questions, let me jump to our very, very small list of things to do. Not unimportant, but small. But let me ask you, are there any questions, not about the exam, because that's what we're going to spend our whole time talking about, but about anything else? Any questions about anything that's been going on in the class or whatever? Okay, I want to mention something calendar-wise. So Friday, you better all know what's going to happen Friday. What's happening? Yeah, Friday's the exam, and just to let you know, format-wise, it's exactly the same as exam 1, whether you like it or not. There are no other alternatives. So it's going to be Proctorio. There is no Zoom. I'm not going to go on to Zoom on Friday, so don't bother logging into Zoom. I'll be checking my email just in case there's any issues trying to get in or something. The good news is the weather's supposed to be good, so hopefully they don't turn the electricity off. I think I'm the only one that has no electricity right now, right? So I don't think any of you all have any issues, right? Including my one neighbor I know in the class, but it's just my street is out, it's a blackout right now. So that's why I'm in Sacramento. And then hopefully your street doesn't get hit. Okay, Alpine County, all good? Good, good. Yeah, so the good news is there's no wind going on. Wind is the biggest danger because that's when they turn off everything. And I don't think there's supposed to be any wind on Friday, so that's a good sign. But let's hope everything goes well. And again, the process will be the same. I won't be on Zoom, but I'll be checking my email in case you have any issues. And the reason I'm not going to be on Zoom is not because I don't want to be on Zoom. I don't want to encourage you to go on Zoom because I've found that Zoom and Proctorio don't work together. So if you try to, talk to me on Zoom while you're on Proctorio, it usually just dies on your computer. Okay, especially with like cheap computers like the one I've got. So again, you want to, have your computer completely focused on just the Proctorio and nothing else open. The exam will be a 2-hour exam. Sorry, an hour and 45-minute exam is what I meant, just like before. Starting at 8:30 for most of you, and then ending at 10:15. So that's the exam schedule. Okay, and in terms of what to bring, obviously your computer. That's all you need to bring. Okay, you're welcome to have a piece of blank paper that you can show to the Proctorio screen at the beginning if you want to. Otherwise, nothing. Just all you're allowed to have is your computer, and that should do it. And I can't do too much about that. It's just the way it is right now. Next year when I teach calc, hopefully we'll be back. So you might get me for, one of the second-year calculus classes if that's what you teach. But unfortunately, we're like this all year, all academic year. Sorry about that. So that's a note. Then Monday there won't be a quiz because there's no section to go over. So I'm not going to start with a quiz like we usually do. So just note is that we're going to start at 8:30 on Monday, and I'll just go over the exam. So that's just kind of what I'll be noting about Monday, because this is it for talking to you. I won't be talking to you on Friday. I'll just be, I don't know, sitting around hoping there's no emails saying I'm in trouble. So anyhow, Monday, there won't be a quiz. It'll be going over the exam and a lecture. So that's the plan for Monday. I figure I should tell you now because there's no other chance. Any questions about anything? Any questions? Okay, I didn't do an extra Proctorio practice because again, y'all did that for the exam one. So you know what's at you at Proctorio. If you had any troubles with exam one, make sure it doesn't happen on exam two in terms of technology troubles. So if something happened to your computer or something, then you still can get one from the college, but my guess is things haven't changed in the last few weeks. Any questions about any of that? Okay, let's talk about exam two. And I don't even know how long we'll talk. We'll see. This could end early if there's no questions or anything. But exam two is written, done, posted. Again, you'll start, on the morning of Friday. And don't forget, you got to bring your ID, your photo ID. That could be your driver's license, passport, your college photo ID is fine. Any photo ID is fine. Question one is exactly the same question as exam one. Now, who remembers what that was? Better all get it. You got it on exam one, so you're okay with it. Yeah, and not just state your name. You're not stating your name. You're actually agreeing to the policy. And I think I recopied it. Yeah. So question number one. Question number one is you're not to communicate with any adult, and you're not to use any device or material for this exam that has not been already expressly allowed by your instructor. Okay, so that's same thing. By the way, the final exam is going to have the same question one also. I always put that on for the Proctorio test. So that again, you know what it is. And the main thing is make sure that you set aside those that hour and 45 minutes to be by yourself, to be uninterrupted, get that cell phone away from you, and just have your computer in front and be ready to go. So if there's any other adults in your household, just tell them, don't bother me. Okay. Children are different. I'm a big believer in, not ignoring children, but, and children means prepubescent is the rule. So again, make sure that you have that quiet time to take your exam so that you're not distracted. And that's very important. Okay. Then comes question 2, 3, 4, and 5. Very simple. Okay, or at least the question is simple, and that is find f prime. Okay, that's a huge part of this exam, by the way. Okay, if you don't know how to find a derivative, you will fail this exam. And you shouldn't be surprised about that either. I mean, isn't that what we've been doing the last, 3 weeks or so, is finding derivatives? Okay, so I'm just going to give you function, and you're going to have to find the derivative. And so what are all the things that we should be thinking about in finding the derivative? There are a bunch of formulas, and these are formulas you need to have memorized. Okay, what are the formulas, or what are the names of the formulas? How about? Because they're hard to type in the chat box in terms of the formula themselves, but the names are easy. And there's a group, there's more than one. Yeah, product is one, chain rule is another. What's another? Good, the quotient or quotient, yeah, the quotient, the trig functions. Okay, there's more. There's the easiest one that no one's writing. There's a few easy, no one wrote the easy ones. Maybe they're so easy you don't even have to worry. Yeah, there's the power rule. There's e to the x. What else is there? 2 more. One's hard and one's easy. One's pretty easy. Yeah, there's ln of x. That's the easy one. Good. And then inverse. And I'm going to say inverse means inverse general and inverse trig, because those are separate. So the inverse general, remember that was f inverse prime is 1 over f prime of f inverse of x. But then there was also the inverse trig functions. And do you remember the 3 that I told you you're responsible for? Because there's 6 inverse trig functions, but 3 are important. Can you remember which 3? Yeah, the sine, the inverse tangent, and the inverse secant. You need to have those in your brain, okay? And whatever it takes, whether it's flashcards or singing whatever it takes, you could dance along as you say them, however it takes for you to get that stuck in your brain, all those different rules and formulas, you need to have that, or problems 2, 3, 4, and 5 will go horribly for you. But if you do have them down, these should be easy. Okay. For some of you, the biggest challenge might be typing, because that could be a pain. And those are such as sine inverse of x. Yeah. So for example, sine inverse, maybe I'll even write this one out. Maybe I'll write them out because we have time. So let's give you the formulas. So derivative formulas. Okay. Let me just go in order at which we did them. So power rule. And that was the derivative of x to the n equals nx to the n minus 1. Very important. Okay. In fact, if you can't do the power rule, you'll fail this test, because I think most of the problems on the whole test involve the power rule somewhere. There's like an x squared or something like that. Okay, but I don't think anyone has problems with the power rule. Okay, then there was the product rule, I think was our next one. And that was the derivative of f of x times g of x was equal to f prime of x times g of x plus f of x times g prime of x. Then there was the quotient rule. Okay, and the quotient rule was the derivative of f of x over g of x and I always remember it from the poem, low d high minus high d low, square the bottom and away you go. So that means it's equal to low, which is g of x, times d high, which is f prime of x, then minus, and then high, which is f of x, times d low, that's g prime of x. Square the bottom means g squared, or g of x squared. And away you go. And that's the quotient rule. Any questions so far? Okay, then after the quotient rule was the chain rule. Okay, and that was the derivative of f of g of x was equal to f prime of g of x times g prime of x. And just note it's f prime of g of x, not f prime of x. Okay, that's really important. Okay, so that's a power, product, quotient, chain. And then we have a few by, we have a bunch by itself, and that is the derivative. Let's go trig. Derivative of the sine of x was the cosine of x. The derivative of the cosine of x was the negative sine of x. And I like to remember that all the cos are negative and all the non-cos are positive. So kind of a good mnemonic to remember is that co, just think about, just co is a negative thing. Got it? All right, so then we have the derivative of the tangent of x. Doesn't matter the order. Equals the secant squared of x. And then we had the derivative of the secant of x. Was the secant of x times the tangent of x. Okay, and I want to let you know something because a lot of people make a mistake here. It's the secant of x times the tangent of x, not the secant of the tangent. If that x isn't there, it's not right. So this first x has to be there if you're doing chain rule, whatever the inside is. So don't forget that. Again, that's the number one mistake I see on trig derivatives, is to write secant of tangent of x, which is wrong. It's the product of secant and tangent, not the composition. Very important to keep that in mind. Okay, then we have the derivative. Sorry if this is boring, but I figure we can go over these. The derivative of the
I can do for you.
cotangent.
Check the clothes in the drawer. I made that was the only
And
thing that that's
Derivative
me
of the
that kept me
cotangent
up
of
last night.
x. I'm gonna, let's see, mute yourself. I don't know who it is, but mute yourself if there's people behind you talking. Okay, so the derivative of the cotangent of x is, again, we got a co, so it's negative. And it's the negative cosecant of x squared. And then we have the derivative of the, what's left? I haven't done the cosecant of x. And that's supposed to be negative. You know what? I'm out of space here, so. Let's go there. So we're going to have derivative of the cosecant of x is equal to negative cosecant of x cotangent of x. So I find the easier way of remembering these is not to memorize all six, but to memorize the sine, the tangent, and the secant, because I told you those were the three important ones. And then just remember that if you do the co, you put a negative and a co. And it always works. All three of them are that. Any questions on that? Okay, so that's those are the main trig. Let me go inverse trig. And I'm only going to do the three that I told you have to memorize. And the inverse trig is the following. We're going to take a derivative. And we're taking the sine inverse of x. And that is going to be the fraction 1 over the square root of 1 minus x squared and then we'll take the derivative of the tangent inverse of x. And that was the fraction 1 over 1 plus x squared. And then we have the derivative of the secant of x. And that is equal to 1 over x times the square root of x squared minus 1. Any questions at all on these so far? Okay, just know there's a reason why you don't need to know the other three. And it has to do with the fact that there's a nice identity. So for example, like, you'd think that cosine inverse would be important, right? Because cosine and sine are both important functions, right? So why isn't cosine inverse important? Okay, and it has to do with I figure I should do it because otherwise it's this big mystery, and there's no real mystery, but it has to do with a little bit of work. I'm going to write it down here and up. And that is, if you want to look at the cosine inverse and kind of understand it, well, what you can do is you can do the old switch the x and y and solve. So you can say that x equals cosine of y. Any questions on that? But the cosine of y is going to be the sine of pi over 2 minus y. Okay, that's actually called the complementary angle, and that works for every co. Any questions so far? And then if we solve for y, then what we can say is take an arcsine, and you get the arcsine of x is pi over 2 minus y, or y is pi over 2 minus the arcsine of y, of x, I mean. So y equals pi over 2 minus the arcsine of x. So here's the idea, is that if we're looking at the derivative of y, that's what we want, then that's the same thing as negative the derivative of the inverse sine. Pi over 2 goes away when you take a derivative, right? Derivative of constant is 0, and the negatives hangs out. So it turns out there's nothing special. And that's the reason why you don't need to know the co's. And this works for all the co's. Pi over 2 minus the regular one inverse. So if you're wondering, why am I only focusing on the non-co's, that's the reason, is because this formula, the complementary angle formula, tells you that really these are almost the same functions anyway. They're only off by a constant and a negative, and constants and negatives are no big deal with derivatives because the derivative of constant is 0 and the negative just hangs out. So that's the reason why there's only 3 that are important. So if you're wondering, since I never showed you that, I figure I better show you that. So it's not just because, I have my favorite 3. It's truly because you don't need the others. Okay, then we also have a bunch more. Then we have the exponential. And that is, and I'm going to give you a couple formulas. They're important. The derivative of e to the x is equal to e to the x. It's my favorite. So pretty. And then the derivative of ln of x, that we need to know for this quiz today, was 1 over x. And then if you happen to have a base that isn't the natural base, so like 2 or 7 or something like that instead of e, then you can still do those. They're a little messier though. The derivative of b to the x is equal to b to the x ln of b. Okay, do you remember those? And then the derivative of log base b of x was equal to the ln of 1 over x ln of b. So those are exponentials. Maybe I'll write exponential and log. Because that's what they really are. Any questions on those? A lot of formulas. This is like the formula test. And then the last one is the general inverse. And that is that the derivative of f inverse, what happened? There it is. Of x was equal to 1 over the derivative of evaluated at f inverse of x. Any questions? Any questions at all on this very long list of derivatives? Okay, the good news is this is all of them. Okay, as I mentioned, we're done. As in, we're done with learning how to find derivatives. You know how to find every derivative of every function now. Okay. I'll let you know, by the way, next quarter. Remember what I told you next quarter is going to be doing? The whole goal of next quarter? Yeah, you do it backwards. And unlike this quarter, you're never going to find the antiderivative of every function. It's actually, there is no method to do, there's no set of rules that gives you all of them. It gives you a lot of nice ones, but it turns out that there just can't get them all in what's called closed form. So it seems like if you go forward, you should always go backwards, but it doesn't work that way. Is that sometimes you just can't do it. So next quarter is actually much harder in terms of taking the antiderivative is much harder than taking the derivative. And that's why, we're done with, we're going to finish week 7. We really finished week 6. We were done with learning how to take a derivative. And then the whole second half of the class is just applications. So any questions at all on these formulas? Okay, so to let you know, I'm just going to give you a function. And guess what? You're going to have to find the derivative. So that's what a bunch of problems are going to be. This is problems 2, 3, 4, and 5. I'm going to give you a function. And I will let you know a lot of the problems, maybe all of them, of the 2, 3, 4, and 5, you're gonna have to do more than one of those formulas because they could be mixed. You could have a chain rule and product rule together. You could have an inverse tan and a quotient rule. That definitely you could do multiple things. So be ready for that. And for the chain, you could have a chain of a chain of a chain. I mean, you could have a function of a function of a function of a function and take a derivative. So the problems are actually pretty messy looking. They don't take that long. And in fact, when I did the key, that was a short part of doing the key. The longer part was the applications, which we'll talk about in a second. So any questions at all on the first part of the test, 2, 3, 4, and 5, which is a big part? Okay, so let me go through and talk about what comes after that. So it's problem number 6. So that's I call it calculus geometry. Okay. So a couple things. One is, what is the geometric word for derivative? What's the geometric word for derivative? Yeah, slope. Okay. And slope of the tangent line. Okay. So be ready. If I asked you for the slope of the tangent line, you need to know how to do that. If I asked you for the equation of a tangent line, you should be able to do that. I could ask you, when do the 2 tangent lines intersect? And you should be able to do that because you know how to find the intersection of 2 lines with basic algebra. I could ask you, when is the tangent line horizontal? And then you should know how to do that. So you should be able to do kind of very basic geometry questions that use calculus by thinking about tangent lines. Okay, any questions on that? Okay, so that's number 6. Then number 7, 8, and 9 are application questions. What kind of application questions what kind of application problems have we worked with? Kind of what were the big classifying words of them? Yeah, related rates. DV, I'm gonna use a word though instead. Differentials. Okay. And what else? This one's a harder one because it was right after the first exam, so you probably forgot about it already. Yeah, it's not a harder question, but it's harder to remember because it's been longer, not because it's harder math. It's probably easier math than the other 2. You remember? Came right after exam 1. It's amazing what memories do, don't they? When I say it, you'll say, of course. You remember? All right, if you don't, velocity and acceleration. Do you remember that? We had a section on that right after the first exam. Does that ring a bell at all? I hope so. Okay, so you'll notice, by the way, it's not coincidental that there's a 7, 8, and a 9. Because how many sections have we had of applications? Yeah, 3, so I gave you 1 per problem. Okay. Pretty standard, but standard isn't necessarily easy. Although with you guys, I'm actually confused because usually related rates are this brutal section. That's what everyone gets wrong. And then differentials, what everyone gets right. With you guys, it was the exact opposite. You like aced the related rates quiz and you died on the differentials quiz. And I don't understand it at all. I don't know. Maybe it's an online thing because I haven't taught online with this class. But yeah, blame the pandemic. That we could do with everything. You can blame the pandemic on any issues or any strangeness. But whatever it is for you, practice all 3. And that's the most important thing. Don't just say, I understand these problems, so I'm ready for the test. Now, you need to sit there and practice. And I recommend practicing at the computer instead of just on paper, because the test is on the computer and you want to get used to typing. And again, I hate it, and I know some of you hate it too, but we're there and I can't do anything about it. So it has to be done on a computer. We're not allowed at the college. Okay. In fact, that's why I'm here in Sacramento right now, because I couldn't go to the college and teach, even though I have no electricity at home. So, so practice at the computer, type things out. Okay. Which is a little awkward, especially with the problems that involve any kind of pictures. So sorry about that, but there's not a lot I can do about it. Okay, so that's 7, 8, and 9. And then number 10 is a critical point / extrema problem. And I probably don't have to go over an example of that since I already did today. When did I go over an example of that today? Yeah, the quiz. Okay. So a lot of people do best on the most recent things because it's fresher in your memory, especially the people that don't study much. But that's bad. I don't recommend you don't study, because then you'll do well on the last problem, and you'll die on the rest of them. So make sure you do study and practice a lot of the older stuff. Okay, so number 10 is going to be, you know, not the same problem as a quiz, but the same ideas. Okay, and then number 11 and number 12 are true, false, and explain. Now you've been doing true, false questions on the homework assignments, or the, what I guess everything's home on the chapter assignments, I should call it, or chapter section assignments. The difference though is for the exam, it's like exam 1, is that you can't just say true or false. You also have to explain why it's true or why it's false. So basically these are proof problems. If I say the word proof, everyone freaks out, but that's what you have to do, is these are to do proofs. And so a good practice of those is to go back and look at the true false questions that you had to do on the homeworks, redo them on pencil and paper, and don't just write true, but write a full explanation. So, and maybe even not pencil and paper, but typed in like a Word document or something. So you get used to typing. So very important to be able to do true false kind of problems. Okay. I want to mention something with the 2, 3, 4, and 5, because it is in there, even though I didn't say it, and I figured I'd better. And that is, sometimes you want to find f prime, but you're given the expression implicitly instead of explicitly. So remember, we had a section on implicit differentiation. So there's one of those 2, 3, 4, and 5 is going to be an implicit differentiation problem. And that's when you have x's and y's on the same side of the equation. You usually can't solve for x and y, but you know how to do it by taking the derivative of every term. And don't forget product rule and chain rule and quotient rule while you're doing that. Okay, so I figured I mentioned that. And that is the exam. Hopefully you'll all do well on it. I'll tell you, my life would be so easy if everyone gets everything right. God, grading is so easy. I could just say wonderful on every problem. And that's it. I do have a question for you, because I know that my stat students were having troubles. Were you able to see my comments that I put on your exam, on exam 1? Okay, if one person did, then you can. Okay, I'll tell you what it is. Maybe you shouldn't tell my stat students this, but calculus students are smart. And then there's stat students. They're all dumb, but you guys are definitely at the top of the league in terms of being able to handle computers. So I don't know. They were all complaining that they couldn't see it, and I didn't do anything different for them than I did for you. But I just wanted to make sure that you were able to see my comments on the first exam that I did on each problem. Yeah, so I don't know what it is about them. It's a challenge. You guys are definitely not challenging that way, because you're in calculus, which means you're already proven that you're top of the group, top of the college. No, I use exactly the same software practice, and I doubled and triple checked it after they complained. Yeah, so it's not a software issue. No, it's the ability to be able to use technology well. And I don't think it was tricky, because I can't see it like you guys can, because I don't grade my own test and look at it. It doesn't quite work that way. And especially with Proctorio, I can't do it. So I just have to trust you that it works. Okay, so I'm going to do the same thing. It takes many hours, by the way, to type these comments. So I want to make sure that you can read them. Otherwise, I don't want to waste my time. But it is important for you to read comments. My plan, by the way, is I'm going to start grading on Friday. And I will finish by Saturday, maybe earlier. But again, I typed lots of comments, so it takes hours and hours to grade these things. But I'm not a procrastinator, so it will be done by Saturday, maybe by Friday is the plan. Okay, so you'll be able to check your grade. Again, I don't think there's any reason for me to like wait and grade it a few days later or something, because no one's happy about that. So any questions about the exam? Any questions at all about the exam? What's the best way to study all this info? Okay, so here is my suggestion. Okay, one thing is that the quizzes are probably the best indicators or the best examples of exam problem types. And what I did while you were taking your quiz is I actually went to all the other quizzes since the first exam, and I made it so it is now open. Okay, you can't improve your grade, by the way. But what I do is I have the all quizzes closing at 8:55 a.m. And that way it's over when it's over. But then you can't look at it again. But I just made it so you can. The only one that you can't look at is today's. And if I remember, hopefully if I don't, remind me, I'll get that one after I grade it, then I'll open that one back up again. But I want to grade it first. And I'll grade it today. So that's probably the best way of handling, of practicing, is redoing your quiz problems. Okay, and the real reason why those are better than homework problems or book problems is they're on the computer and they are problems that you type out your answers instead of check a box or type in a number and you're done, which is what the assignments are. And the book problems are not written by me. So that's why the quiz problems are all written by me. So that's, you get my style of problems. Whether you like it or not, that's my style. So, so that's one suggestion, is to go back and redo each quiz. You can also go and look at the webinars if you have no idea how to do the quiz, because remember, I always go through the answers to the quizzes. And in case you can't do it, but don't do that. Like, don't look at the answer to the quiz. Try to do it without looking at the answer, so that you practice doing a problem instead of reading a problem. So that's important. And you're typing it out and all that. Does that make sense? That's number one. Number two is I recommend going back to the chapter section assignments and doing all the true falses, but typing out your explanations instead of just saying true or false. And by the way, on the exam, don't forget to say true or false. Don't just explain and then don't say if it's true or false, because I'll take off points. So it's a combination of half for true or false and about half for the explanation. That's typically how I grade. So you gotta do both. So practice that. And I wrote all the true false questions, by the way. So they weren't in the original set of problems, but since that's my style, I put in true false questions. And now they're in there. So the good news is that, that's written by me also. Some of the homework problems I wrote, most I didn't actually. Most are written by my team. Okay, that when I say homework, I mean the chapter section exercises. Okay, can I name the 3 types of applications? Let me type this in. So the first one is, let me just write velocity and acceleration. And the second one was related rates. And the third one was differentials and error. Okay, and when I say error, I mean also percent error. Does that help? Okay, so, and when I say velocity acceleration, let me write down some more, and other rates of change. So for example, if you just hear the word rate, what's another word for the word rate in our class? Here's a hint, it's the most important word there is in our class. Yeah, derivative, okay. In economics, what's the word for derivative? It's been a while. Starts with an M. No, profit's not a derivative. Profit is actually typically just the regular function. Yeah, marginal. Okay, so marginal was the word for derivative in economics. Okay, and I can give you any of these kind of things. Okay, and I won't feel guilty if I give you one of these because we had a section on it. Okay, so if there's problems in lecture on it, then I'll give it to you. Any questions on that? Any questions? And I want to let you know, and this was a bit awkward, but I didn't really know how to handle it. Again, I'm learning it myself. In the related rate problem that you have to do, and of course there's going to be one, it's hard. It's hard without a picture. So I do recommend you bringing some paper and pencil and to draw the picture, and then in your work shown, just describe what you drew. It's really hard to draw pictures on the computer. Okay, it doesn't have a good drawing tool like that. So just describe in words what you drew. And that'll help you get credit. And I want to let you know, if you don't show your work, I can't give you credit. And in fact, the instructions on the exam, this time I wanted, because some people said, I didn't tell you how to do show work. Instead of each problem, I just wrote at the very beginning, show all your work. You have to show your work. Okay, that's very important, especially calculus work. But the way you show the related rates picture work is just write a few words on what you drew. And that's how you show that work. And even if you get the problem wrong, if you drew the right picture and described it, I'll give you some points just for doing that. Does that make sense? Okay. Are there other questions before I ask you one? Other questions that you might have? No extra credit. You only get extra credit on the first exam of every class that I teach. So when you take third quarter with me, if you need to take third quarter, then on that first exam you'll get an extra credit, the same extra credit problem. So that's just I always do that extra credit problem on the first exam because I need time to kind of see how to change it. At this point, there's not a lot left in the class, so that's why I do it on the first one. Other questions? Okay, if there's no question, I have a question for you. And that is, and you can give me a number if you want. Let me know what kind of example you want, 1 through 12. Let's say number 1. And then I'll write an example and let you try, and then we'll do it. Okay, number 12. Okay, or maybe I'll do 11. I'm just kidding. Okay, so let's do true, false. Okay, those are actually the hardest for me to just make up. The 2 through 5 or so, those are 6, or those are the easy ones because that's just find the derivative. But let me make up a true, false. So answer the following, true or false. And explain your reasoning. Might take a second for me to think of a good one. And now let me think. How about if g of x has a critical point at x equals -7, then f of g of x also has a critical point at x equals -7. Okay, I'm going to give you a couple minutes. I want you to try it first. Again, it doesn't help to just watch me do a problem. It's much more important for you to try. Okay, and this exact problem is not on the test, but I just want to give you a problem that I would come up with that could be, maybe I'll give it the next year or something. That's a nice little problem. So I'm going to give you a couple minutes of just trying to work it out. And again, I would write down the word true or false at the end, not at the beginning, because you don't know until you actually do some stuff. And again, don't just think about it, type out your answer, because that's how you want to practice. So I'll give you a little bit longer and then I'll go over it. Okay, let's go over it. All right, so when you read this, if g of x has a critical point at x equals -7, then f of g of x also has a critical point at x equals -7. So let's go to the word critical point. That's obviously the big word of this problem. And when do functions have critical points? You got to remember the definition. The hint is there's two different things that could happen. What are the two different things? Derivative equals 0. And what's the other one? Change in slope. No, the slope could always be changing. It could go from 0.03 to 0.04. Derivative equals 0, but there's one other case besides derivative equals 0. Not differentiable. Okay, so we're going to have two cases. So case one is we have the critical point is a critical point because g prime of -7 does not exist. All right, D and E. Then, well, if g prime of -7 doesn't exist, if g is not differentiable, f of g is also not differentiable. Guess I need to do this in equation form. We had a theorem about that. Okay, may not remember, but it happened a long time ago. Okay, so far so good, because if it's not differentiable, it's a critical point, right? Okay, case two. And that is g prime of -7 is 0. Okay, we know it's a critical point, so one of those two things must be true. Then, well, what is the derivative of f of g of x? What rule do we have to use? Yeah, there's a chain rule. So then let me copy this guy so I'm going to type it again. The derivative of g of f of x is equal to g prime of, that's right, is, let me write it as f prime. Oh, sorry, I got it backwards. Retype it. Sorry about that. It was f of g. And similarly, f of g. Will be f prime evaluated at g of x times g prime of x. That's the chain rule. What happens if we plug in -7? Yeah, at x equal -7, this is f prime of g of -7 times 0, because g prime of -7 is 0. But anything times 0 is 0. Okay. So either way, guess what? We're in good shape. So what's the answer? In one word? Not a trick question. Look at the question. True. Any questions on that? Did I lose anybody on this explanation? Okay, so either you have a critical, either you have a point of non-differentiability, but if you do, then the composition is still not differentiable, or you have the derivative of 0 for g. So therefore, by the chain rule, the derivative is 0 for f of g. So either way, you have a critical point. So that's true. Any questions? Any questions on this example? As I mentioned many times, is that it's a lot easier to watch me do it than to do it yourself. And that's why I gave you a couple minutes to try yourself. So you get that down. Maybe you all thought it was really easy to do yourself too, but my guess is no. So it is, important that you can do this yourself instead of say, oh, I totally understood what he did. That doesn't mean you can do it. You need to practice. All right, so give me another number. Since I just did the true false one, maybe you can give me a number from, how about 1 to 10 instead of 1 to 12? All right, I can take the first request, which is related rate change in angle, okay? So let's do that. All right, let me do a question. And by the way, I just a warning, when I give the test, I don't write, this is a related rates problem. So make sure you can, know what kind of problem it is and practice enough so that you know to do related rates to start. Obviously, I'm about to give you a related rates problem or, because you asked for it. Okay, so that's just a big note. Okay, well, let's suppose that you are driving at 40 miles per hour up to Echo Summit. Where, let's see if I want to say this. You can drive 40 miles per hour at Echo Summit. Okay, along a grade that is, let's see. Oh, you know what? That won't work. You want to change Vangel formula. So I got to pick another one. It's not easy to just immediately come up with an example. So let me come up with a different example. So how about, here's a good one. Suppose you are in a boat and drop a not sure how you spell that. Oh, it looks like it's okay. Seki dish. That didn't like it. From a horizontal pole that is 2 meters long. And the dish sinks into the water at a rate of, how about 0.3 meters per second. Okay. How fast is the angle changing that you're looking down at? When the dish is let's go 12 meters below your site. Okay, if it's not perfect language, I apologize. It's hard to just jump into one of these problems, but I'd probably make it a little nicer on a test, but coming up with these last ones. I'll just give you a minute, at least to set it up, because we only have 4 minutes left of class. And if I gave you the full 5 minutes, that's already past it, and then I don't have time to show it. Yeah. The one word I should probably put in here at a constant rate. But that's kind of obvious. And if you're wondering, a Secchi dish, that's the dish they use to measure the clarity of the lake. They drop a little plate down and they watch it until they can't see it anymore. And then they call it, that's the depth of clarity. So if you decide to work for UC Davis as an environmental scientist, you might be doing this someday. Okay, I think I want to talk about it. And the key is step 1. Is draw the triangle. That has base, I'm going to say at the top, so horizontal base. Two, because that's not changing, okay? So the distance from the horizontal distance isn't changing. What's changing is the vertical distance. So it has base 2. Any questions on that? Okay, and it goes down. So it goes across 2, then goes down. So height, I don't know, how about call it y? Any questions on that? Base 2 and height y. Okay, so we have a right triangle, it has base 2 and height y. And then if you look at the triangle, if you've drawn the same triangle, then the next thing is to think about the trig that relates the angle to what you want and what's known. And notice, by the way, actually, is that we know that dy over dt is equal to 0.3, because that's given. And what we want is we want to find the rate of change of the angle, and that is d theta dt. All right, equals, we don't know, question mark. Any questions so far? Any questions? Okay, so then we want to find out a relationship between y and theta, and we're given that 2 is a horizontal distance, and you'll notice that the tangent of theta is y over 2. because it's the opposite over the adjacent. Okay, any questions on that so far? Okay, now we just take a derivative with respect to t on both sides. And hopefully, because it's on our list of things that you need to know, what is the derivative of the tangent of theta? And that was the secant squared of theta times d theta dt. So that was equal to the derivative of y over 2, which is just 1/2 dy over dt. Ah, shoot. What's the next step? Yeah, we plug in. So now we're going to plug in. And what we get, I'm just going to copy and paste it and then put in as I go. So secant of theta, well, the secant is the hypotenuse over the adjacent. The adjacent is 2. Notice that we're at 12 meters. Well, we know that that means the opposite is 12. And the hypotenuse is going to be the square root of 12 squared plus 2 squared, which is the square root of 148. Okay, so then you're going to take the 2 over the square root of 148. And that'll be your, sorry, the other way around. Square root of 148 over 2, because it's secant. And then d theta dt, that is what we want. So we leave that one, equals 1/2 dy dt, and dy dt is 0.3. And then the rest is busy work. So d theta dt, I think we're out of time, way out of time, so I'm just going to say it. D theta dt now, if you multiply by the square root of 2 over root 148, the 2 and 1/2 cancel, and you get 0.3 times the square root of 148, and that's your answer. But I just realized I'm way past my time, so I am going to stop the sharing and recording.